Chapter 17 review for the test. We see we have 15 multiple choice questions here. Number 1, the work. When you're reading a problem, again, you want to pull out keywords. So a keyword here is work. Required to move a charge of 3 coulombs through a potential difference of 12 volts. So we see that V is equal to 12 volts, Q is equal to 3 coulombs, and we want to find the work. We remember that work is equal to the change in energy. So work is equal to Q times V. The basic equation is that V is equal to W over Q. So I rearrange the equation to solve for the unknown in terms of the known. So 3 times 12 is equal to 36. Number 2, if 15 joules of work, so W is equal to 15 joules, is required to move 3 coulombs of charge between 2 points, the potential difference. So remember, potential difference is the voltage drop. And sometimes you'll see, sometimes they'll say voltage, but the potential difference. So that's V, and the work is equal to the change in energy, which is, again, delta PE. So delta V is equal to delta PE over Q, which is 15 joules divided by 3 coulombs, which would be 5 volts. Number 3, $20 joules of work is done in transferring 5 coulombs of charge between 2 points. The potential difference is, and this actually is lowercase q. Lowercase q is a point charge, capital Q is an area charge. The potential difference. So we want to find the potential difference, which is V. So we know that V is equal to delta PE over Q, which is W over Q, because work is equal to the change in energy. So it's equal to 20 joules over 5 coulombs, which is 4 volts. And you'll notice that in just about all these problems, the math is such that you could do it in your head. Number 4, if 12 coulombs of electric charge pass through a point in 4 seconds, so we see that this is Q, this is T. What's the current? Current is I. So I is equal to Q over T, so it's 12 coulombs over 4 seconds, which is 3 amps. What we see in this chapter is, in order to succeed on the test, there's quite a few equations. So nothing really has a high degree of difficulty. There's just quite a few equations you have to remember. And if you look at the back of your notes, that table, and it has all the variables, it has the units. It's important to look at the units, and it has all the equations on the last page of the notes. Okay, number 5, 20 coulombs, so that's Q, of charge pass a given point in a conductor in 4 seconds. What's the current? So again, I is equal to Q over T, so 20 over 4 is 5. Number 6, the number of electrons that pass a certain point in a conductor. So this is actually the same as before, but this is in words. So let's look at this. The number of electrons that pass a certain point is defined as, so in words, what's that mean? It's the charge per unit time. So charge is what? Q. Time is T, and Q over T is equal to I. This is the type of problem if you write down the words and you see it, and you say, oh, charge per time, Q over T, oh, that's I, and then you'll look at the equation. So that is going to be the current. The more you write down on paper, the less likely you are to make a mistake. So whether it's something like this, and they're giving you something in words. Number 7, which diagram best represents the relationship between the length of a metal conductor and resistance? So what I'll do is I'll look at the choices. Now, we said that there's 4 things that affect the resistance of a wire. Okay? And one of them was length. So as the length increases, the resistance increases, and they're directly proportional. Well, first of all, I can eliminate this choice, these two, because I see with these two, as the length increases, the resistance decreases. So I can just right away eliminate these two. Then these are my 2 choices. This one is exponential, and this one is linear. And they're directly proportional, so that shows a direct variation. Number 8, as the temperature, so again, this goes back to the table in your notes of the 4 things that affect resistance. So as the temperature of a coil of copper wire increases, the electrical resistance increases, because the word here is resistance. So as I heat up copper, which is a good conductor of electricity, the temperature is going to decrease its conductivity, but when it decreases its conductivity, that means it's going to increase the resistance, because remember, the word resistance means to resist, so it hinders the flow of electricity, right? Number 9, if the diameter, so again, this goes back to that same table about resistance. If the diameter of a wire was to increase, its electrical resistance would decrease. So again, you can visualize water flowing through the pipe. If I have a narrow one or I have a really wide one, more water is going to flow or more current is going to flow, so the resistance is going to decrease because more is going to be able to go through. Number 10, which voltage would cause a current? Do you see how when I'm reading the problem, I'm chunking it? Every time I read a value, I'm figuring out what that is. Now on the test, you would just write V, I is equal to 0.5, and then a resistance of 24 ohms. So right away, when I see these 3 variables, I'm going to say Ohm's law. Now in the next chapter, when we get to complex circuits, we're going to be using Ohm's law over and over and over again. So first I write my basic equation, V is equal to IR, and I want to solve for V, so 0.5 times 24 is equal to 12 volts. Number 11, a lamp has a current, so I is equal to 2 amps, at 6 volts. The resistance, so V is equal to IR. And I know a lot of times with 3 variables, we just want to do this in our head, so we're going to rearrange the equation to solve for the unknown in terms of the known. So R is equal to V over I, which is 6 divided by 2, which would be 3. Number 12, the slope of the line on the graph represents, so slope, okay? So first of all, what is the slope? This is a straight line, and I know that the slope of a straight line is delta y over delta x. So this is y, and this is x. So this is going to be potential difference. And you see that if I write it down, it helps me to visualize and conceptualize. I'm not just trying to memorize something, because memorization doesn't help, divided by the current. So that's going to be V over I. So what is V over I? Well, let's think that's right. I know that V is equal to IR, so V divided by I is equal to R. And that's it. That's the resistance. So that's a good way to do these types of problems. Number 13, what is the current, that's I, through a 25 ohm resistor, R, connected to a 5 volt battery supply, that's V. So V is equal to IR, I is equal to V over R, which is 5 divided by 25, which comes out to be 0.2. Number 14, the ratio of the potential difference, so potential difference is V, across a metallic conductor to the current, that's I, is known as, so what is V divided by I? V divided by I is R. And the last multiple choice question, the work. Whenever I see the word work, the first thing that pops up in my mind is what? Work is the change in energy. 2 coulombs of charge, so that's Q, over a potential difference of 5 volts. So V is equal to delta PE over Q, and which is W over Q. So W is equal to VQ, which is 5 volts times 2 coulombs, so 5 times 2 is 10. And again, most of these problems, the math, the numbers are simple that you can do the math in your head. Okay? So the key to doing the multiple choice questions is the more you write down on your scrap paper, the back of your FRQ, the less likely you are to make a mistake. The suggestion is take the back of your scrap paper, hold it like this, side by side, just like I did, put a piece of paper here, and then write down everything that you need to know. Well, I don't know if people are still copying that. But if you put it side by side like this, okay, and as you work it step by step and you identify, this is what I'm given, this is what I want to find. And this is a strategy not just for physics, this is going to be with any class. The more you write down on paper, the less likely you are to make a mistake.